Hi, today, our topic for our group is the use of antibiotics in food animals. The members in our group are Amber Wickham, Katrina Suarez, Caitlin Freitas, Jasmine Garza, and Jeanette Morales, and our position is against. Next slide, please. This is Katrina speaking. So first, some history of antibiotics. Antibiotics were first discovered in 1928 by Dr. Alexander Fleming with his finding of penicillin. Antibiotics were first majorly used during World War II with the mass production of penicillin for the soldiers. But antibiotics did not start being used in livestock until 1949. The first animal to be given antibiotics was a chick. They were given vitamin B12 used from fermentation instead of other sources, which gave them a higher growth efficiency. Next slide. Antibiotic background. Antibiotics are substances that can destroy bacteria in livestock and humans. Antibiotics are used in animals' water and feed to improve growth, feed efficiency, treat clinical diseases, and disease control. The improved growth helps market and production animals grow faster in a shorter period of time so we can get the most out of them at their most valuable ages. Feed efficiency so we can get the most out of our feed without using large amounts of it. Antibiotics help treat clinical diseases along with disease control so a disease does not come into a herd or come back to the herd. Antibiotics are used in two different contexts, therapy and growth. Therapy is to treat and control clinical diseases, and growth to help market and production animals grow at the fastest rate possible. Then, 80% of the antibiotics that are sold and produced in the United States are used in animals, while only 19% are used in humans. Next slide, please. Ethical views. First, the risk to human health. Antibiotics have a wide and overuse, which then creates superbugs and other life-threatening diseases. This poses to be the biggest risk to human health with animals being fed antibiotics. This is because the high resistance that bacteria creates can spread from consuming the animal protein to the humans. Superbugs are created when one type of antibiotic is used over and over again to treat one type of bacteria, resulting in the bacteria becoming used to the antibiotic agents, and then they no longer become effective. This then also results in many treatments becoming less effective and making these diseases and infections stronger and stronger, making them even harder to get rid of in the long run. Next slide, please. Next, the potential damages for animal welfare. Antibiotics can help eliminate many diseases, but then they also create more diseases for the animal to have to fight off. Also, when antibiotics kill off one type of bacteria, they are then creating more room for other unknown types of bacteria to enter the animal's body, resulting in more things for the animal to have to fight off. And this then also creates new diseases for the animal to have to figure out how to deal with, and it results in harder cures that are more effective to find. Next slide, please. Sociological importance. Antibiotic resistance. Antibiotic resistance is the biggest public health challenge in the United States to both animals and humans. Each time an antibiotic is used, it spreads antibiotic resistance since the bacteria is getting used to the antibiotic agents and no longer becoming affected by it. Antibiotic resistance is spread through people, animals, and the environment. Next slide, please. Antibiotics become less effective and lose the effectiveness of their treatment the more they are used on one type of bacteria, since they are getting used to the agents within the bacteria and are becoming stronger to help stay alive in the animal system. But the CDC is coming up with a solution to fight off antibiotic resistance in animals, which is reducing the unnecessary need of antibiotics in an animal's diet. This program is the NRP, which is the U.S. National Produced Program. This program reduces the small amounts of leftover antibiotics given to an animal, so that way that we are using not as much antibiotics and the bacteria isn't able to figure out how to fight off the antibiotic instead of the antibiotic fighting off the bacteria. Next slide.
All right, this is Amber now on current events. The current events regarding this issue, using antibiotics in food animals, are at an increasingly improving rate. The FDA shows signs of purchasing antibiotics for food animals to be declining in numbers. Statistics from a 2016 to 2017 study shows that domestic sales and distribution have decreased 33%. The FDA actually made a new rule to be implemented a few years ago, January 1st, 2017, under Guidance for Industry number 213. This rule states specific antibiotics that are important in modern medicine cannot be used in livestock anymore. So the main antibiotics that we rely on in modern medicine, such as the example from 1928 World War, penicillin, that one is also an antibiotic not to be used because of the importance that we rely on. As of today, the current change to improve this issue is to require less over-the-counter availability. 95% of important antibiotics in animal, water, and feed for therapeutic reasons require veterinarian oversight. So this not only makes it harder for a farmer to get these antibiotics, but it does cost a lot more having a vet come out to their farm. So they tend to use these antibiotics not in a wastingly manner to preserve their costs. There's actually a 2015 organic cattle farmer in New York who told his story of organic cattle farming. He bought 13 bulls at $5,000 a head. And after many animals dying and more than $100,000 trying to save the rest with necropsies and other implications that didn't include antibiotics, this farmer still supports organic farming. After losing tons and tons of money, he still chooses to not use antibiotics in his farming. And it also takes him about twice as long to get to market. And he's claimed it's about 27 months for him to get to market without the use of antibiotics. So the informed opinion on the against side here is that animals do carry amounts of bacteria in their gut, and this bacteria can be antibiotic resistant, creating many health problems. This can get transferred from animal to consumer, causing these deathly problems such as 23,000 deaths in America yearly and 34 billion in financial losses for farmers and even patients. There are many antibiotic treatments involving cattle that can be important for production and important for animal health. However, they do seem to be a bit excessive from the normal eye, such as lactating dairy cows and clinical mastitis. So 16% of all lactating dairy cows in the US get antibiotic therapy for clinical mastitis each year, but nearly all dairy cows get intramammary infusions of prophylactic doses of antibiotics following each lactation to prevent and control future mastitis. So, this prophylactic dose of antibiotics after each lactation is extremely excessive, as dairy cows do lactate quite often as they keep producing calves and stuff. Another example is beef calves and respiratory diseases. 15% of beef calves that enter feedlots get antibiotics for the treatment of clinical respiratory disease. But therapeutic antibiotic doses are also administered to 10% of healthy calves to prevent anticipated outbreaks of respiratory disease. So not only do they treat 15% of beef calves, they also do 10% of just the healthy calves to prevent this disease, to prevent costing them more money in the future if the calves do develop this disease. However, this antibiotic is not needed at the time. Another example is beef calves and tylosin. 42% of beef calves in feedlots are fed tylosin to prevent liver abscesses that negatively impact growth. Also, about 88% of growing swine in the United States receive antibiotics in their feed for disease prevention and growth promotion purposes, commonly known for tetracyclines or tylosin. So this is one of the ones that people use for growth purposes, just for their own benefit. So they not only increase the tragic risk for antibiotic resistance, but they also do it just for their own gain. And this one is definitely unnecessary for the beef calves, and even in the pork industry, 88% of the growing swine, which is a significant amount. In conclusion, antibiotics create one of the biggest health risks for humans by creating a resistance to antibiotics through the transition of eating animals. So this issue first started with penicillin, causing people to be immune to the beneficial effects of penicillin. This was started in 1928 with the World War, and doctors administered different things to bypass this. Changes today are to come, though, as farmers have been limited to what antibiotics they can give, how much they can even give. They are limited to the doses and how often they can give it, and at what time frame before slaughter they can even use it. So some farmers, depending on what they are farming, cattle, pork, poultry, whatever, they have a certain time frame where before their animals go to slaughter, they cannot have any ounce of antibiotics given to them in that time frame, or they will not be allowed to be taken to slaughter. However, with the bacteria in the gut, it is possible that there will be some residue in the gut left over, and that is how a good portion of people get the antibiotic resistance. In light of the many cases, however, caused from the situation, it is best to limit and be aware of the antibiotics being administered to the food animals that we consume, not only for our benefit, but for the excessive benefits of the farmers um, using this antibiotic for their one leg up and for the risk of the health of the consumer. Thank you. These are our references that we used, mine for antibiotic resistance and the studies, and another reference page for Katrina's journals and antibiotics and animal feeds we used.